The next problems in the chapter have to do with transformers, which turn one current and voltage into a different current and voltage using induction. So we have a neon sign that requires a voltage of 11,000 volts, and it's plugged into an 120 volt wall outlet. So coming in, that's our primary voltage, is 120 volts. And going out, which is our secondary voltage, we need to have 11,000 volts. Okay, so I want to know what's the ratio of turns that you have to have on that transformer. So our equation is just that the ratio of turns, NS over NP, is equal to VS over VP. So the ratio of voltages is equal to the same as the ratio of turns. And so now I just have to plug and chug. So 11,000 is my voltage on the secondary, 120 on the primary. So I need to have a ratio of turns of 91.7. And I could use that. So if I had been told how many turns there were on the primary or on the secondary, I could figure out how many turns there were on the other coil. So that's pretty straightforward. The only trick is just make sure you look at the equations and make sure you get the ratio the correct way up. All right, let's do another problem. So we have a step-up transformer, has 25 turns on the primary, so NP is 25, and 500 turns on the secondary. NS is 500. If this transformer is to produce an output voltage, so that means voltage on the secondary, and output is 4,800 volts, and the output on the current of 12 milliamps. So IS is 12 milliamps, or 12 times 10 to the minus 3 amps. Then it says what input current and voltage are needed. So I want to know what's the current on the primary and what's the voltage on the primary. Okay, so what are we going to use? Well, we're just going to use those equations that we had. So let's do the equation that we had up in problem 5. NS over NP equals VS over VP. And I'm trying to find VP. So the first thing I'm going to do is just cross multiply. So I get NS VP is equal to VS times NP. And I want to find VP, so now I'm going to divide both sides by NS. So VP is equal to VS times NP over NS. Right, make sure you do the problems carefully like this. It's easy to get the ratio the wrong way around if you don't do it step by step. All right, so now we know everything. So we just now plug and chug. So VS, my secondary voltage, output voltage is 4,800 volts. I've got 25 turns on the primary, and I've got 500 turns on the secondary. All right, and so I'm going to get a voltage, an input voltage of 240 volts. Right, remember a step-up transformer takes a small voltage and turns into a big voltage. So I have 240 volts going in and 4,800 volts going out. So that confirms it is a step-up transformer. All right, now let's do the current. So for the current, the ratio is the other way up. So I've got NS over NP is equal to IP over IS. And I want to find IP. So again, I'm going to first cross multiply. All right, so cross multiply, I get NS IS equals NP IP. I want to find IP, so I'm going to just divide both sides by NP. So I get IP is equal to IS times NS over NP. So now I just plug and chug. So IS is 12 milliamps, 12 times 10 to the minus 3 amps. Number of turns on the secondary is 500. Number of turns on the primary is 25. And so I get 0.24 amps. Right, so remember, when the voltage goes up, the current goes down, and vice versa. Right, so my input voltage is 240 volts. My input current is 0.24